Hello guys, and welcome back to my YouTube channel. In our previous video we saw definition of insertion sort and then see an diagram of how we can achieve insertion sort, and then we implement insertion sort using linked list. After that we saw the time complexity and space complexity of insertion sort. So in today's video we will see merge sort. So let's get into it. The merge sort algorithm is a sorting algorithm that is based on divide and conquer strategy. This divide and conquer strategy is very good strategy when you want to reduce the time complexity of an algorithm. Binary search tree also use this divide and conquer approach for sorting things. In this algorithm, the array is initially divided into two equal halves and they are combined in a sorted manner. Merge sort working process. Think of it as a recursive algorithm continuously splitting the array into half unit. It cannot be further divided. This means that if the array becomes empty or has only one element left, the dividing will stop. In the base case, to stop the recursion, if the array has multiple elements, split the array into halves and recursively invoke the merge sort on each of the halves. Finally, when both the halves are sorted, the merge operation is applied. Merge operation is the process of taking two smaller sorted array and combining them into eventually longer array. So now let's take a look at the illustration. To know the functioning of merge sort, let's consider an array of 38, 27, 43, 3, 9, 82 and 10. At first check if the left index of array is less than the right index. If yes, then calculate the midpoint. Here we consider I as the left index and R as the right index. So if I mean left index is less than R, then we will calculate it midpoint. Now, as we already know that merge sort first divides the whole array iteratively into equal halves unless the atomic values are achieved, mean unless only one element is remained in the array. Here we see that an array of 7 items is divided into two arrays of size 4 and 3 respectively. Now again find the left index. Now again find that is left index is less than the right index for both array. If found yes, then again calculate the midpoint for both the arrays. So in this case our midpoint will be this between 3 and 9, and it will divide this array into two. Now further divide these two arrays into fourth halves until the atomic unit of array is reached and further division is not possible. So we will keep dividing this array like this, and after that we will again until these atomic value mean only one element is left in each cell is achieved. After dividing the array into smallest unit, start merging the element again based on comparison of size of the element. First compare the element for each list and then combine them into another list in a sorted manner like this. After the final merging, the list looked like this. So we have this 27 and 38 on left side, and then right side we have 3 and 43. When we will merge it in an ascending order, so 3 come first, followed by 27, then 38, then 43, and same goes for these two. First 10, first 9, then 10, then 82. Now after this merge is complete, now it's time for the merge of these two subarrays. So we will also merge them via comparing in ascending order. So 3, 9, 10, 27, 38, 43, and then 82. Now this following diagram shows the complete merge sort process for an for example, for an array of these 9 elements. If we take a closer look at the diagram, we can see that the array is recursively dividing into 2 halves till the size become 1. Once the size become 1, the merge process comes into the action and start merging the arrays back till the complete array is merged. So these number indicate that the order in which the step is processed. So at the first we divide our first array into 2 halves, and then we keep on doing that until we achieve this atomic value level. After achieving this atomic value level, we start to merge these arrays in an ascending order manner. So now it's time for our algorithm for the merge sort. So at step 1 we start our program. Step 2 we declare array and left and right and the mid variables. So basically we will be declaring 3 variables, left, right and mid variable. At step 3 we perform the merge function. If left is greater than right, then return. Then we will define our mid, left plus right divided by 2, and then the merge sort algorithm, we will pass it array, left and mid, and then again merge sort function, and we will pass it array, then mid plus 1 and the right, and then we will call our main merge function, and then our function will be stopped and our array will be sorted using merge sort algorithm. So let's start the program for our merge sort algorithm. It will be a bit more complex than all the previous sorting algorithm that we have seen so far. So first I will write our function of merge. It will be of void type void merge. Then it will accept for, or let me first define our function of merge sort, because we will be calling our function merge from the merge sort function. So first merge sort, it will be easy for you to understand. So first will come our merge sort. It will accept 3 parameter, an integer type array, then a constant begin, then our const of end. So if the begin is greater than or equal to the end, then we will simply return. It will be a recursive return. after that we will define our mid. It will be begin plus and minus begin and divided by 2. After that we will call our merge sort again and we'll pass it our array begin and mid. After that we call our merge sort again and we'll pass it our array mid plus 1 and end. Array mid plus 1 and our end. After that we will finally call our main merge algorithm or merge function and we'll pass it our array begin mid and end. So now it is showing us that merge is not defined because we still have not defined our merge function. So let's define our merge function on the top of our merge sort function. It will be a void type of function. It will accept an array, then integer const left, then an integer const mid, and after that an integer type of constant variable right. So now here we will define our sub array. It will be a auto const sub array 1 it will be equal to mid minus left plus 1. Now our auto const sub array 2 it will be equal to right minus mid. Now we will create our temporary array. Array 1 now our right array will be equal to a new integer type of array 2. Now we will copy data to our temporary arrays left array. and the right temporary array. We will be using our for loop, where we will be define auto I is equal to 0 and I less than sub array 1 and increment I by 1. So inside of the body of our for loop, we'll define our left array ith index equal to our array left plus I index. So that's all from today's video. The video is already got much bigger. We will continue our this code of merge sort algorithm in C++ in our next video. Till then, take care.